Okay, here I have the line class, and I've broken it up into two columns, but these are both part of the line class, so I go from line 23 to 24 on the right-hand side. On the bottom right, I've got a main method, and what I want you to do is try and draw memory at the end of that main method. So please pause it here and try and draw out what memory is going to look like, tracing each line of that main method. Okay, so I've got a main method, so I'll draw the stack frame for that. And in the main method, I have two local variables. One is args, which is the input, and I'm going to write that as null, even though it's actually a 0-length array. The other local variable is myLine. To see what that's going to reference, I have to look at the constructor. And I look at the line class and it doesn't have a constructor. Okay, so when a Java class doesn't have a constructor, we get a default constructor that takes no arguments. And all it does is provide any of the initialization that's provided when we create the instance variables. So if I look at lines 2 and 3, I can see that a line object has two instance variables. So even without the constructor, I can see that my line object is going to have two instance variables, one named points and one named labels. And both points and labels get set for every line object that's created. So points is an array of double variables, and there are 4 of those. And we typically draw arrays just like we would the actual variable, but then we glue here 4 of them next to each other. So those are all variables that can hold a double. Since we're not giving it explicit values, we get the default value for a double, which is 0. To remind ourselves that they are doubles, I will write 0.0 in each of these. That's similar to how when we create an int array, we get a bunch of zeros. Labels is going to be an array of strings, and there's 2 string variables in that array. And because we're not giving those values, it'll start as the same as the default for a string variable. And so that is going to start at null if we haven't given it a value. Okay, so that's the right-hand side of line 43 where we called the constructor, and then we set myLine equal to that. So we set myLine to reference that line object. My next line of code, myLine.setX1 to be 3.3. So line 24 shows the method setX1, and what it says to do is to set this dot points at index 0 to whatever that input is. So I want to remind you that when we would call setX1, that would create a new stack frame. And since we called it on the variable myLine, we'd have a variable inside of there called this that referenced exactly the same thing as myLine. So when we're tracing the code, it says this dot points, okay, and then index 0, that's the first index, that's going to get the value of input. Oh, I'm sorry, setX1 also has the variable input, and in this case we gave it 3.3. And remember, we put primitives like a double inside the box, but this is a reference to an object, and so that one's an arrow. Okay, so again, on line 44, we call setX1. We call it on the line object myLine. So our this references the same thing that myLine does, and we passed it the input of 3.3. Okay, and then it says this points at index 0. That thing becomes whatever input is. So we make a copy of 3.3 and we put it there. You might just have to trust me that that says 3.3. Once setX1 finishes running, like once we make that change, then this stack frame setX1 just disappears. Okay, so that wouldn't be here anymore. Next we'd call setY1 to be 4.4, and we would get something similar. So we might be able to trace this one without drawing the stack frame. So I know my this is going to refer to exactly the same thing as myLine. So my this is that line object. And then I'm going to set points at index 2, so index 0, 1, 2, and I'm going to set that to be my input, which was 4.4. Okay, now myLine.setEndLabel. This one's a little more interesting because we're working with a string, so I'll draw the stack frame. And it's going to have 2 variables in it. It has this. Since we called it on the object myLine, this is going to represent that line object. And remember, it doesn't matter where on that object we point to. We're just saying, hey, this is referencing that line object. And then the input is of type string, and the variable name is still input. But because input is a string and not a primitive, that string that we get is going to be an reference with an arrow, so that's ONT. So that's all just calling set end label. Now the body of set end label is going to say this, okay, that's my line object, dot labels, okay, so dot labels, and then at index 0. So that index 0 is going to set to be pointing to exactly what input points to. So now this one is no longer null, and index 0 is going to point to ONT. And again, once that code executes in set end label, that stack frame disappears. Okay, my picture got pretty messy, but here's what it should look like in the end. I'm not showing those method stack frames from set x1, set y1, or set end label. Once the code in those methods finishes executing, that stack frame disappears. And so if you're drawing memory on what it looks like at the end of the main method, we actually only have the main method stack frame left. And as you're getting used to this, you might want to draw every stack frame that will happen and then cross it out. But once you get a bit more used to tracing the code, you can probably do it without drawing those stack frames. Okay, we're not done. Did you notice that we had a typo in set start and end label? Like probably we didn't want to have both of those set index 0. Yeah, that typo was intentional. And maybe I decide here that I would like to redesign my line class. So what I'm going to do is I'm going to refactor it. And refactoring means that I'm going to change the underlying code, but I'm not going to change how someone interacts with that code. So I still want to achieve the same exact functionality. So any test cases that worked for my line class, those should still work for my line class after my refactoring. So I want you to try and refactor this code to no longer use arrays. And instead of using arrays, I want you to use variables that have human understandable names. And that idea of writing code where all the variables have human understandable names is really important for writing code that is likely to have fewer bugs and is likely to be easier to debug or change in the future. Okay, so pause the video and then next I'll just show the answer. Okay, so here's my answer where I've changed it, and you can check out in the one where I had the bug before, where you can imagine it's super easy to like have a 0 versus a 1 and kind of forget to keep track. Here inside set start label and set end label, it's much clearer that we've got it correct. This dot start gets input, or this dot end gets input. So going back to the previous code, we might want to have things that use arrays, but the extent to which our code just relies on the fact that like we've typed a 0 or a 1 or a 2 or a 3 in there, that is not good style. So here, I can't change set x1 without knowing that I would also have to change get x1. And that hidden dependency is something we really try and avoid. And we'll look at other strategies for avoiding that, but here we can just see that, oh, if we hadn't used arrays, we might have had something that was easier to understand and maintain.